All right, mathletes, here we go. Looking at Venn diagrams. So Venn diagrams consist of a universal set U. So you always want to make sure with Venn diagrams that you draw your rectangle box representing your universal set. Everything within your universal set should appear in that rectangle. Okay? Subsets within that are generally represented by circles. So notice the subset A is a subset of our universal set. Notice everything outside of A is the complement of A. So that shaded region there in the green is the complement of A. Okay. Here in this diagram, you can see when B is inside our set A, okay, and it's completely inside. Every element in B is in A. We can say that B is a subset of A. Okay, so let's look at some other ways we can look at Venn diagrams. Okay, so when we have intersections of two sets, so intersection is this upside down U. So the intersection of A and B is where these two circles overlap. So elements in this region, okay, are going to be the intersection of A, B. The union of two sets A and B consists of all the elements. So we can see in this diagram here, if we bring all the elements together in A and in B is going to be represented by this region here, A union B. If we have disjoint sets, also known as mutually exclusive, things that cannot happen at the same time, there is no common elements, will look like this, that there is two sets and there is no overlapping in either of the sets. So then they are mutually exclusive or disjoint. Okay, so here in this example, we're going to be talking about rolling an ordinary die. So the universal set of the possible outcomes are the numbers 1 through 6. Okay, illustrate on the Venn diagram the sets. Okay, so here in part A, when we're writing this, we want to make sure that we label our universal set U. So that is what's in the box. Okay, so if I have this set A, okay, and this set B, okay, I always like to look for the intersections first and label those. So I see that 1 is in both sets A and B, so that needs to be labeled there, 1. Okay, there is no other elements in the intersection of A and B, so then I'm going to write the other elements. So in A, 2 needs to be there. In B, 3 and 4 are there. Well, I got to remember in my universal set, I have the digits 1 through 6. So I'm missing 5 and 6. So they're in the universal set, but not in the set B and not in the set A. Okay, so let's go ahead and look at B. So again, I draw my two circles. I already have my rectangle drawn. I'm going to label that as my universal set. Label one of the circles A, one of the circles B. I'm going to head and look for points that are common in both. The intersection, so 3 and 5, 3 and 5. So those are going to go there. Okay, in set A, I'm going to go ahead and put in the other ones that are missing. So I can see in set A, I have 1, 3, and 5. Okay, in B is 3 and 5, so there's no elements that are just in B. So we can see that B is a proper subset of A. Okay, so what other elements in our universal set are not in A or B? Well, we're missing 2, we're missing 4, and we're missing 6. So they're in our universal set here. Okay, if we wanted to, we could draw this separately, and we could draw B completely inside of A because it's a subset, but it's not necessary. In C, again, I'm going to draw my circles, label A, label B, label my universal set. Okay, look for my intersection points. So 3 and 5, I have no points in the intersection. Okay, so these are actually disjoint sets. Okay, and I can go ahead and label 2, 4, and 6 and A. And in B, I'm going to label 3 and 5. And the one that I'm missing is 1 in my universal set there. Okay. So on my last example here, D, okay, I have all the odd numbers in A and all the even numbers in B. If I draw this, I can draw these because I have no intersection. Like I did in C, I could also draw this as disjoint sets. So this is A and this is B, because I can already look and see that there is no overlap of elements. Okay, so in A, I have elements 1, 3, and 5. And in B, I have elements 2, 4, and 6. Okay, let's look at another idea here. So in Venn diagrams, regions, we can use shading to show various sets. For example, two intersecting sets A and B, we have these different shaded regions. So we can see the intersection of A and B, we shade it in this region where it's A and B. Okay. If I want to shade the region of A, it'd look like this. I'd shade everything in A. That might also be in B. Okay. So if I'm talking about shading things that are not in B, I look at my universal set as my rectangle and I shade everywhere that's outside of my B. And we get that stuff in the pink. Okay. So here A intersect B prime. So remember B prime is not, so not in B. Okay. Or the complement of B, also known as. So what is shaded, what is in A but not in B? Well, that's where we get this region. Okay. And it's that kind of moon looking shape there. Okay. So on these diagrams, we want to shade the regions that are being discussed there. So in A union B, okay, A union B is everything in A and everything in B. So I know it's going to be everything in A, everything in B, and I shade that region. That is the union of A and B. Okay. For complement of A intersect in B. So this is everything in B that's not in A. Okay, so everything in B but not in A is going to be that region. Okay, and the last one here, we look at A intersect B but not in that. Well, I know A intersect B would be this middle region right here. So if I want everything that's not in the intersection, it's going to be everything else other than that intersection point or that intersection region. So we'd be just going to skirt around that ellipse there. Okay, so that is the complement of A intersect B. Okay, so numbers and regions. So for many problems in Venn diagrams, we are interested in how many elements are in each region, but not which elements these are necessarily. Sometimes listing every element in that region is a lot of work. So anytime we see Numbers written with brackets, that's representing the number of elements within that region. Okay, so in this example, how many elements are in these regions? So in P, okay, well, we have to remember that these 5 are also in P, even though they're in Q. So the number of elements in P's region, we got to do 8 plus 5. So we have 13. Okay. So P union Q, well, that's everything in this region. So we got to do 8 plus 5 plus 9. So then we're going to get 22. Okay. So in the complement of Q. So in Q, let me erase this so we can see in Q we have these 14 elements. So everything that's not in Q for this one, the complement of Q, is going to include 8 and 2, which is going to be 10. Okay? So how many elements are in P but not Q? Well, P not Q is just those. There's 8 elements in P, not in Q, so we're not going to add that intersection. Okay? In E, okay, what's in Q but not P? What's in Q but not P? We have 9 elements. Okay? Neither in P and Q, so that's things that aren't in these subsets P and Q, but appear in our universal set, is going to be 2. Okay, so that's how we can problem solve through that. Okay, in our last example here, we're going to have to try and find how many elements are in some of these regions. Okay, so from our given information. Okay, so our first thing we know is all of our elements in our universal set, there's 40 of them. So I know that these 3 numbers together, A plus B plus C plus D, equals 40. Okay, the number in A. So the number in A in the set A is going to be the number of elements in A plus B. That needs to be equal to 24. Okay. The number of elements in set B needs to be, well, the B, the intersection, plus C, and those need to be equal to 27. Okay. Well, the number of elements in the intersection of A and B is 13. So that's nice because that gives us that number that we know that B is equal to 13. Okay, so now from this we can kind of backwards solve and see what the other elements are. So if B is equal to 13, and I plug it in here, I see that A plus 13 is equal to 24, so A must be equal to 11. Using similar logic, okay, now B is 13, so 13 plus C is equal to 27. So C must be equal to 14. Okay, so I'm going to go ahead and label those there. We can do a little bit better job here. So we see that B is 13. A is 11. I'm going to put brackets here so we see that they're talking about the number of elements in there. And then C is 14. Okay. Now that I know those 3, I can figure out D with this equation. So I can see that A, 11, plus 13, my B, plus my C, which is 14, plus D is equal to 40. Okay? So now that I have my equation, I know that 11 plus 13 plus 14 is going to be 38. plus D is equal to 40. So D is equal to 2 elements. Okay, so now that I have each one of those, I can go ahead and proceed and answer questions on A and B with these things. Okay, so A asks, what is the number of elements in A union B? So those numbers together, that's going to be 11 plus 13 plus 14, which is equal to 38. Okay, and B wants to know the number of elements in A, not in B. Okay, so that's just including, so in A, intersect not B, so that's this region here we're talking about. So that is 11. Okay, that go ahead and concludes our notes today. Please highlight any questions and bring them to class tomorrow.